Hi everyone, we're going to look at calculating the areas between functions of x in this first video. And then the following ones we'll look at kind of some more complicated setups. So let's jump into it. So we already know that integrals calculate the area between the curve and the x-axis. That's what we've talked about. But if we want to find the area between, say, f and g, we can do that by calculating a as the integral from a to b of f of x minus g of x dx. And that's because what we're really doing, if you want to think about it this way instead, is calculating the area from a to b of f of x dx minus the integral of the area from a to b of g of x dx. And this is because we're kind of initially calculating the area under f of x, which you know is this whole area. And then we subtract off the g of x, which is this other cross-hatched area, and that leaves us just behind the blue area. And this works if it's positive and negative and all that stuff, because you know, if you imagine something like this and this, it'll still work because g of x would have a negative area. And so subtracting that negative area would add it to the positive f of x area on top, and it all still works out. So we're always just taking that upper function and subtracting the lower function. In other words, which one is more positive in the terms of the y value minus which one is more negative in the y-axis or the y value. So if it gets more complex, then all we have to do is break it up into sections. So for example here, the area between f of x cubed and g of x is x squared plus x. You'll notice that this f of x cubed is that red line, and g of x equals x squared is the blue line. And the area between the curve is this area right here, plus this area right here. So we can see that between these points, it switches. So initially the red line's on top, then the blue line's on top. And so when we actually go to integrate that, we end up applying that idea. So the area is going to equal the integral from negative 0.618, and that's just the intersection of the two. I'm pulling it off the graph right here, to 0 of, what is it going to be? It'll be the f of x, yes, the red line, minus g of x. And so that takes care of this first part. And the second part, we're going to add it, and that's going to be the integral from 0 to 1.618 of, now it would be g of x minus f of x dx. And so that's our kind of, setup here. It's just taking the upper function minus the lower function off of the graph or off of the, if you use your calculator to find the intersections or you do it by hand, it doesn't matter. But then I'll do a couple more steps here, but leave the rest of it as an exercise for you. So 0.618 to 0 of f of x is x cubed minus x squared minus x dx plus the integral from 0 to 1.618, and g of x should be x squared plus x minus x cubed dx. And if you keep working that, you'll eventually get to an answer of about 1.0833. But pretty simple reverse power rule here, and then plugging in your bounds. So that's the idea behind calculating the area between two functions, just take that upper function minus the lower function, or the one that has a greater y value minus the one that has a lesser y value. And if that switches, you just have to break it up into multiple sections.